welcome to my talk. As I was introduced as, I'm Nick. I'm the co-founder CTO of Sprocket Games, and my talk is how we 10x our playtest velocity for an Unreal Engine game with BuildGraph, TeamCity, Kotlin DSL, and AWS, which is the longest title of any talk I've ever given, I think. So, hi and welcome. Who am I? I'm Nick. I'm the co-founder and CTO at Sprocket Games. It's an all-remote game development studio founded last year. We're 14 people, mostly based out of American time zones. Before that, I was a little alluded to before. I started my career making mobile games at a studio called Jamdat Mobile, where I made Bejeweled for phones, and then transitioned into being a backend developer kind of by trade and into infrastructure. So I went from backend lead on Eve Online at CCP Games into architect on shared platform tech for Riot, and then co-founded Pragma Platform, and now most recently co-founded and am still CTO at Sprocket Games, where all the stuff I'm going to be talking about today was implemented, tested, and kind of deployed. So here's a quick rundown of our agenda for today. First, I want to talk about why CI/CD is important, as people kind of throw around that word or acronym, and sometimes we don't take the time to appreciate why it's important. Then I'll introduce BuildGraph, TeamCity build chains, Kotlin DSL, and then we'll put all that together and show how at Sprocket we did our build and deploy pipeline using all of these things, and then we'll kind of look at the results a little bit. So let's do it. Why apply CI/CD is important. So first we CI, and then we CD. That's it. We're done. Boss, mission accomplished, right? We're done. Okay, but why? Why is this important? What are we trying to achieve? Making builds is cool, or having a CI is fun, but there has to be a reason for this. So at Sprocket, and your mileage may vary, but for us, we think of the end goal of CI/CD as increased studio agility. So our developer time is our most critical resources. A lot of other things are more fungible, but developer time is something we're very careful about. And we make games. This is a game day presentation. So we make games. Games are creative projects, and they're not the easiest project to fully predict or define. It's rare these days to have a full design Bible with everything upfront decided. So what that means is that our ability to test an implementation or a feature and react to that test is super important, more maybe important in other software projects you might encounter. So for us then at Sprocket, CI/CD is a way to make the best use of our developer time, react really quickly to change in product directions, and then experiment and validate our assumptions quickly. And quickly is really important. You'll see it throughout the talk why I think that's so important. So where did we start? Because we'll talk about where we ended up, but it's interesting to think about where we started as a studio. Well, we started like most project or studios. The game was built on a developer machine using build, cook, run. For those that have done Unreal Engine development, that's the kind of the traditional way of building locally your package game. It was manually pushed to a manually provisioned AWS instance, and then we had to manually coordinate uploading that build to shared storage somewhere and have everybody else download it, kind of show up at the same time for a playtest. And we tried to do this roughly once every 2 weeks. We tried sometimes more than that, but it failed. It failed often. It would either not compile, it'd have a nasty breaking bug, it would fail to start. And improving this took real effort. And I've been on many projects throughout my career, and a lot of projects will stay like this for a long time until well late into development. This talk is a story of how we got ahead of this and fixed it before it became a problem for us. So what were the consequences of where we were then? The consequences were we were losing hours of developer time making builds. And this was our top developer trying to make a build that was workable instead of making features and making a game, which is what they would want to be making. We lost developer time to broken syncs. They would sync ahead from Perforce, and then the editor wouldn't compile, or it wouldn't run. We lost the ability to interact with our own game, which perhaps of all the things we lost, that was the worst. We did not have a relationship with the product we were building. We didn't play it very often. We didn't experience it. And that was super detrimental to us. And then we had no clear feedback loop organized to test our implementations and get that feedback and then iterate on those features. So we were frustrated. Everybody was frustrated. No one was happy. And we figured we could do better. So what did we do then? Okay, to get to the point of talking about what we did at Sprocket, I we'll talk about BuildGraph, build chains, and DSL first, and then we'll put it together. So BuildGraph then. The definition from Epic goes something like this. I'm going to read it because it's that good. BuildGraph is a script-based build automation system that features graphs of building blocks common to Unreal Engine projects. BuildGraph integrates with Unreal Build Tool, Automation Tool, and the editor. BuildGraph can also be extended and customized for your projects. That doesn't really say anything, or it's not super helpful as a description, I don't think. So here's my shortened version. BuildGraph transforms the description of your build to a set of tasks and a relationship needed to realize that build and can then run those tasks. That's it. Forget everything else. Just remember that. That's what BuildGraph does. It ships with the engine and is used to build your game. So this is what a BuildGraph kind of script, XML script looks like. You can kind of glean that it's a XML document, and you can also kind of glean that there's a lot of placeholder variable names or stuff that looks like environment variables, really all those $signs, parentheses. These things will be replaced later with parameters to get an actual concrete build. And the output of an export from BuildGraph looks a little bit like this. It's a JSON document, and it specifies build steps and their dependencies. And that seems kind of obvious or unimportant, but it's actually crucial. It's pretty difficult in an abstract way to figure out all the dependencies of the build step and what needs files from where and what needs to run before what. And BuildGraph orchestrates all that, including transferring files from one step to another. Okay, why use it then? BuildCon works, right? It works on your machine. Time-honored tradition of building it on your machine. It works. Why change anything? Well, BuildCon doesn't have any parallelism. It just runs the whole build in one go, start to finish. Okay, that works, but it takes a long time. And if you want to make a CI that reacts and is able to give valuable information back to your developers, it's just too long. There's no way to cut it. It doesn't scale to that. And if you use it, if you do decide to try to use it in CI, we found that the usage is really brittle and hard to maintain. Stuff breaks a lot. You end up writing bespoke script to try to maybe make something that looks like a parallel version of this, but it's not helping you do it. When the tools are not helping you do it, then the tools are wrong. The tools have to help you do it. So using BuildGraph then, you specify your parameterized build description using XML, like the file I showed, and then you can use that to generate any number of actual concrete builds, different branches, different platforms, different configurations. And those graphs will express the underlying concurrency that you're desperately going for, that you need. And then BuildGraph can run the whole script, or it can run parts of that build. And we'll see how we use it a little bit later. At Sprocket, then, all UE builds are expressed in one BuildGraph XML file. And we've so far found that that's not a big problem. It's worked out really well. Maybe it'll change in the future, but so far we're good. Okay, so what does BuildGraph need to run then? It needs a BuildGraph XML script. We went through that. And then it needs a set of concrete values to use as parameters to replace those $sign parentheses things that were everywhere. What are the parameters used for? Configuration to build, platform to build, where to put the result, really anything. It's a pretty generic system, and it has, I wouldn't say it's a programming language because it's not, but it has loops and it has conditionals. So you can do a lot. It's pretty expressive. What do you get then? As we talked about, you get a JSON document listing the build task and their dependencies. Now, what you don't get is a build system, and that's kind of the crux of how we put it all together later. There's no off-the-shelf CI/CD system, including TeamCity, that can interpret BuildGraph exports. No CI/CIs or CI/CD system can do that, except Horde, which we'll talk about later. But that's not production ready, so it's not a real CI/CD system just yet. So, however, it is still a crucial building block, and interestingly, it doesn't contain its own parameters. So that's going to have to be worked around later in how we put it together. Okay. One of BuildGraph's most awesome ability when it comes to building your game is that you can run it locally. So not only can it run a distributed build or a concurrent build, but it can run that sequentially locally. And that has two giant benefits that are uncommon in production grade CI systems. It allows for a local iteration of the build system. So most of the build system I've encountered in my career so far, the way you debug them is to submit to the build farm and hope it works. And that's a very, very slow turnaround thing. Not great. With BuildGraph, you can test it locally, and you are nearly identical to an actual CI build. So you use it to iterate your build system, and you also use it to debug build failures, right? Often in many companies or projects I've been on, you would encounter a build farm failure. Developer says it works on his machine, and you end up down the rabbit hole of chasing what the differences are between that build environment and the other build environment. BuildGraph reduces that a lot. I mean, there's always going to be differences, but there's a lot less with this paradigm. So it's pretty useful. Okay, BuildGraph, done. Build chains. This is a JetBrains talk. People probably know about TeamCity. It's an awesome CI/CD tool. What are build chains? Just so that we're all on the same page. So from the docs, then a build chain is a sequence of builds interconnected by snapshot dependencies. That's a great description, much better than the epic one for BuildGraph. Sometimes they're called pipeline in other CI/CD systems. They connect build configurations together. And the gist of it is they're connected build configurations. You can define them in the UI or via the Kotlin DSL, as we'll do in a little bit. But they have to be defined before the build start, right? They express your build, how it's connected. They're not generated as part of your build. Some people call those dynamic build chains or dynamic pipelines in other unnamed CI/CD systems. These are not it. They're statically defined prior to the start, and that is critically important. Then I'll just touch on one more thing that we're going to use. It's composite build. So if you've used TeamCity, you make build configurations. They have build steps. They produce an output maybe. Composite builds are a little different animals. They have no build steps. Their job is to aggregate the results of other build configurations, and then they can, if they want, re-expose the artifacts of those dependencies. In our system that we're going to show here, we use them to re-expose all artifacts built by all steps of our system. And then the composite build at the end of our build then is the one other parts of our systems depend on. So if you're wanting to get the result of an Unreal Engine game build, then you depend on that composite instead of the parts. That keeps things neat and organized. Graphically, from the UI, which is always a pretty UI in TeamCity, this is what it looks like. And you can see that we start by building an editor, and then we fan out to build on multiple platforms. If you know about building Unreal Engine games, that's kind of the rough steps you'd expect. If you don't, it just is what it is. And then we composite up at the end via the aggregate build all the artifacts. Okay, that's build chains. That should be pretty good. Kotlin DSL. Maybe you know about this, maybe you don't know about this. TeamCity can store its config and source control, and that is great. Please don't use the UI. Please don't go and manually configure your things. If your server disappears, that's really sad, and no one can review changes, and that's not great. So you can store the config as code and source control. You can either store it as an XML document or as Kotlin DSL. I like XML as much as the next person, but I much prefer a programming language, and that's what the Kotlin DSL is. So we can write code then with Kotlin DSL to generate our entire build system programmatically at evaluation time. The way we do that is we create a .teamcity folder at the root of our project, and that's where we're going to put all the DSL stuff. That has a special treatment from TeamCity, gets read and gets executed. So as I said, the Kotlin DSL then is a real programming language. It's a statically typed DSL. It's super well integrated in IntelliJ. You can run it locally to test its output, mostly, which means you can generate your build pipeline locally and see if the number of configuration you expect is about correct. It's not one-to-one. It could use maybe some work, but it's still super useful. However, the most important thing, writing CI config with complete is the most awesome thing. I've done this with many products, many different CI/CD systems, and having a nice, well-featured programming language with autocomplete to author all of this is just a joy. I don't know if it's a drawback, but the limitation perhaps is a better way of describing this of the DSL system as implemented in TeamCity. The DSL is executed only once after TeamCity detects a change in your .teamcity folder. Specifically, what that means is that it will not rerun before a build job. So you cannot create dynamic pipeline, not possible. You have to create your pipeline, and then later on your build will trigger if you do changes to the source tree outside of the .teamcity folder. Apart from that, though, I have not found any limitation using it. Everything I've ever wanted to do with it just worked flawlessly. Okay, we got BuildGraph, we got TeamCity, we got Kotlin DSL, we got a starting point where we have difficulty making builds and doing playtests, and the studio is not working well and is frustrated. So let's put it all together and see what we can come up with. So first, we create a BuildGraph script. That part is pretty easy. If you're using Unreal, do yourself a favor and immediately after this talk, start writing your BuildGraph script if you don't already have one. It's pretty simple, certainly to get started. It can get very complicated. You can do it locally, no problem. There's amazing example in the engine source tree. I will say that the documentation, as is often the case with Unreal Engine, is not necessarily the best or the most up to date, but the source examples are amazing. So go into your engine source tree, find the BuildGraph examples, and work out from there. I highly recommend writing batch files to wrap those BuildGraph invocations for your local development and your developers. No one wants to remember 7 or 8 or 9 or 10 parameters that are needed to start the thing. It'll help you keep things neat and simple. I highly recommend doing this, even if you're going to stop here. Even if you're not going to do CI, if you're not going to do CD, if you just do build on, if you're a solo developer with no source control and it's all local on your machine, please just use BuildGraph. It'll set you up for a CI/CD later. It will make things way more reproducible. So definitely invest sometimes in this if you're using Unreal Engine. Then the other thing that I'll mention, I'm not going to touch on it very deeply in this talk, but if you're going to use BuildGraph, you should take the time to investigate what Unreal or Epic calls Auto SDK, which is their method of distributing standardized SDKs to build environments. So for Sprocket, we use it to deploy our SDKs both to our build machine and our developer machines. And so we keep all version of SDKs in sync across the build farm and the developer machines. And we found that that reduces our false build problems that are due to just versioning difference to an absolute minimum. So definitely look into that too. Okay, so now we have an export from, or we have our BuildGraph script that can define our builds. We can use it to have a JSON file that tells us all the steps, and we can use it to run those steps, but TeamCity doesn't understand BuildGraph or steps or things like that. So we need to somehow transform this into a build chain. And this is where things get a little bit complicated or a little bit difficult. What we would want is when we detect a BuildGraph, something impacting the BuildGraph script changes to generate a new build chain. But that's not really possible, or we haven't found a good way to do it. And that's because running BuildGraph means compiling your project. And you don't have access to your project when the DSL has to run. The DSL runs with only the .teamcity folder, no access to the rest of it. And so it's not quite possible to generate those chains at the moment you would want to in a normal kind of Unreal expected pattern. So concretely, this means no BuildGraph export from Kotlin DSL, no BuildGraph export as a pre-flight step on a build, let's say, or as part of an early step of a chain that would generate a second chain. Other CI systems sometimes can do this. We don't have that luxury in TeamCity, so we got to find a way to work around that. So how do we do that? Well, the path that we followed, the kind we tried, and it worked relatively well for us. And by no means do I mean that this is the only or maybe even the best one, but it worked, so it has that quality. Given that we have to generate all pipelines when the DSL runs, and that we only have access to the .teamcity folder, then we don't have much choice. We're going to put all the exports from BuildGraph in the TeamCity folder, and we're also going to find a way to add the missing parameters to the .teamcity folder to create our build chains. And then when that is true, we can finally write our Kotlin to transform those JSON files into build configurations. So how did we go about doing that? Well, exporting BuildGraph to .teamcity or creating the export file, that's really easy. That's all it takes. If you want to do it running locally, that's all you need to do. The line will get longer as you add parameters, trust me, but at its core, this is what you need to do. So there's no complications here. But it gets real tedious to have to do that manually and for different build chains. And so it's not just doing that manually and stashing it in a .teamcity folder is not the end all be all, but it's not a hard part. It's not a hard step. The solution that we found is to organize our files in what we call job definitions. So inside that, we kind of abused the .teamcity folder a little bit and put more stuff, perhaps that JetBrains ever intended in there. But so far it's working well. So we put our job definition there in the .teamcity folder. For us, these are just oh, I think I'm back now. Somebody should probably confirm that they can hear me on stream. Yep. Oh, okay, cool. Thank you. So then, okay, where was I? Yes, the job definition files. So we start the job definitions in .teamcity. They're JSON files, and they contain the parameters that are needed for the export and the parameters that are needed to run the actual build steps. These are the same, funny enough. You can see what they look like on the right. They're not very complicated. They specify which project we're building, which platforms, which configurations, and so on and so forth. And these are arbitrary. You can add as many as you want. And we can use them then to export our stuff. So what this looks like in our .teamcity folder, if we kind of take a look concretely at what ours looks like, we have jobs definition. They're in the jobs folder there at the top. And then we need the JSON export of BuildGraph. These are inside the JSON export folder. The kind of less great part about this is that developers have to refresh manually the JSON exports whenever they change something that causes BuildGraph to change. And that's quite a lot of things. Changing the XML script causes that. Changing the engine source code, which we do from time to time, might change that too. Changing the parameters of the job certainly will do that. And so we kind of just abstract that all away by having a little Python script called refresh all there. If you have a key now, you might have spotted it. And that just refreshes all of our JSON exports, and we just run it whenever we feel like it might be needed. And it takes care of all of our perforce checkout, perforce check-in of all our .teamcity files. So it pays dividends to treat your developers well and make their life easy. They will use your tool, and talking to build engineers here in particular, they will use your tool way more if they don't have to remember how, or if it's very, very easy. So then, okay, cool. We have job definitions, we have BuildGraph export. Now we can finally use Kotlin DSL to turn them into build chains. In BuildGraph parlance, stuff is organized in groups and nodes and dependencies, and these will map literally one-to-one to build configuration, build steps, and snapshot dependencies. We wrap everything up in a composite build at the end, collect the artifact, expose that, and then we organize everything in neat little sub-projects to keep our UI clean and good looking. In the UI, it looks like this. So this is our incremental builder. It runs after any check-in in the game, and it tells us if we broke the compilation of the game on any of our target platforms. And you can see that we expose only the aggregate really in terms of what's useful on a daily basis. All the BuildGraph step are hidden inside a sub-project, and that's because normally, unless it breaks, we don't really care about them. They just run, and we're happy to not see them kind of pollute our UI. How does this work? How do we write this Kotlin DSL? Where do we write it? Well, when you onboard onto Kotlin DSL's way of storing your TeamCity configuration, everything will be rooted in a settings.kt file that will be stored in, of course, the .teamcity folder. This is a little snippet of our code that we run to do that, and you can see that we've a kind of a extension method there for those that speak Kotlin called BuildGraph build type. And this is, of course, not standard out of the box, but you can add it because it's a programming language fully featured. You can extend this DSL to your own needs. And this was our need to build BuildGraph projects for Unreal. But if you wanted to build something different, you can just as well add more stuff like this. So we defined a build type then to extend the DSL to support BuildGraph. The way we tie everything together there, you see the little cheeky name equal incremental. The BuildGraph build type name has to match a file that isn't present in both the JSON and the JSON export, or the job definition and the JSON export. If that's the case, no problem. We generate the build chain for it. If it's not the case, we just error out and keep using the old definitions of the pipeline from the previous DSL run, which is great. Okay, I'm not going to show all the code that's needed to transform BuildGraph export into a TeamCity build chain. Suffice to say that it pays to go and learn Kotlin. If you haven't played around with it, please do yourself a favor and go play with it. Our game is a C++ game. Our backend is mostly Kotlin. It's that good of a language. It's not just a DSL for TeamCity. Do yourself a favor, go learn it. It is great. We make extension methods to kind of follow the DSL style. You can kind of see that at the top. And then we make class extensions or classes to do our BuildGraph type. And that works super, super well. Super, super well. No problem at all. The result looks a little bit like this. You've seen the slide as I've alluded. I've added the artifacts here. So what this kind of shows you is that TeamCity now knows how to invoke BuildGraph step by step. Instead of invoking BuildGraph to run one process and start to finish, it can involve the sub-step. Now, BuildGraph will take care behind the scene of synchronizing the files it need in between its dependencies, so long as we give it a place to put those files, more on that later. And then TeamCity will collect the artifacts from all the packaging steps and re-expose them as one nice, kind of easy to depend on composite build. And this has been working super well for us. Okay, where do we run this then? Yeah, I don't have 12 machines at home. Or where do you want to run this? For now, at Sprocket, and this may change, this will likely change. For now, we run all builders on AWS. We use non-spot instances, which is weird, but you'll see why in a second. We create them from a launch template, so they're all standardized. We add them to a TeamCity Cloud profile. If you haven't looked at TeamCity Cloud profile, also go look at that. Super powerful, great way to save a ton of money. TeamCity will then stop and start our instances as needed. So even though we're not using spot instances, we are only paying for the compute minutes that we need to build our game. This is useful because we don't work much on weekends, so there's not much need to run all those machines. And the reason we use non-spot, because of course would be cheaper to use spot instances, is because we want to reuse intermediate build products. This is anathema in general CI/CD circles to not main clean builds, but Unreal is so long to build that it's kind of, you don't really have a choice if you want an answer in minutes to did someone break the build to reuse prior build products. So we don't make clean builds for every incremental build. The inter-agent storage that I talked about earlier is stored in the cloud on AWS FSx as an OpenZFS share and mounted on all the build agents. And BuildGraph takes care of cleaning that up and moving the files that are needed before and after build steps, kind of automatically. We start all our builds in S3 using the S3 plugin for TeamCity, and that also works super good. So if you're interested in not storing them on your server, the S3 plugin is a great thing you can use. What about our deployments? Well, they're all defined in Kotlin DSL as well, because once you start doing that, you're not going to want to stop. We use templated build configurations. You can see it there on the fourth line where I call templates, deploy to template. This allows you to kind of abstract even more jobs that are similar to each other. So this one is how we deploy to our daily environment, when and some information you need to kind of go and do that. It's all stored in .teamcity, configuration as code. We love it. Works super good. Okay, graphically what that looks like for those more graphically inclined, we take BuildGraph plus our job definition, we put that in a Python script, and that spews out all the files we need to then give to TeamCity. TeamCity takes over, runs the Kotlin DSL, generates our pipeline. When the pipeline runs from code changes, we put the results in S3, and then TeamCity can be used to deploy those artifacts from S3 to our Amazon game server instances, our Steam beta branches, and our Play Store internal tracks. And this is how Sprocketeers can then get there in the morning, open the Steam client, and just get in the playtest. Okay, so let's look at what changed when we did this, and perhaps what would change for you if you went on a journey of doing something like this. Developers can now build, cook, and package their game locally, fully, and easily. They have nice little scripts that do exactly what they need them to do, and it just runs BuildGraph locally, and they don't know the difference, and it makes them a local build, and that's great. We use AutoSDK, like I said, to distribute our SDKs, keeps our tooling consistent, super good. And then we use BuildGraphs so that they can run either before a check-in to validate that with high likelihood that the build won't break, or after a break to triage why it might have broken if it wasn't broken prior to that. Our release builds run nightly and on demand. They take about 2 hours, which is long in the world of making builds, but not so long in the world of making Unreal Engine deployment builds. We have plans to make that faster, but it's good enough for us at the moment. It allows us to run them nightly, and it allows us to run them in the morning before the playtest if we have a critical issue that would endanger that day's playtest. Our incremental builder run on all change lists, and they run in about 20 minutes, both for PC and mobile platforms, for Linux and Windows builds. And that's fast enough for developers to wait for the result when they check in. And it's a critical metric. How fast you need to make them is exactly how fast your developers are willing to wait before they go home or go for dinner or do something else, and stop caring about if they've broken the build or not. And so 20 minutes for us is just fine. It's fast enough that right now we don't coalesce changes very often or nearly at all, which is great. Doing it for every CL means it's easy to pinpoint where the failure comes from. If you coalesce too many changes, people start to blame each other, and then it's a rabbit hole of figuring out why it's broken. We're very careful about where we report failures and successes. We try to keep Slack spam to an absolute minimum, so the signal to noise ratio is really, really good. By the way, you can send Slack notification easily from TeamCity, so service messages cannot be used for that. You just, if you are interested in that, ping me after or go look into service messages. They are great. The failures then and the recoveries, and only the recoveries, are reported to a dedicated Slack channel, CI failure as we call it. And so if a message goes there, something's broken that shouldn't have been broken, and we're all kind of keen to jump on it and go fix it. The build outcomes are reported to CI builds, and you see it as I have muted there for those that are keen-eyed Slack users. And that's because it's quite noisy, and we only really go and wait on our build when we check in something in that channel. If not, it's more informational than it is useful. Perhaps the most amazing metrics that we've discovered is our time to fix. So even with all our local running abilities and our diligence around not wanting to break the build and be good to each other, we still break it roughly about twice a week, which for us, we work 4 days a week. That's every other day. And that may seem like it's not that much, but it has impact, and so it needs to be addressed. Now, we have an average, we track the average time to acknowledge a failure, and it's about 10 minutes, which is great. This is post CI notification. And the incredible metrics that we found is that we submit a fix on average 22 minutes after a break. And that is very, very fast. The credit to that is because we don't have too many changes, because the developers themselves are looking at this channel, they have full context. They know generally what was broken, and it can be fixed really quickly. I should add that this is compile errors or blueprint errors. This is not automated testing, deep game introspection breakage. These do still happen, and they're not caught, of course, by this system. As I said, we deploy every morning, and we can also deploy on demand to our testing instances, our Steam beta branches, and our Play Store internal tracks. It takes about 10 minutes to deploy to all of this and get an environment to a new version. We have the ability to go back and forward between any release candidate. I highly recommend you build yourself those capabilities as well. You will have to go back sometimes or do funny games with your deployments. We promote our builds between two environments, and that's good for now. We have our daily environment, nightly deployed via continuous delivery, TeamCity, of course, and then the playtest environment, which we manually deploy to via build promotion within TeamCity. That allows us to have a super high velocity iteration with the daily test, but also a stable environment at all times for demonstration. And we used to lose a lot of time when the moment came to make a build for demonstration. It was a very stressful thing, but because we keep one around and just do the hard thing all the time, it became not hard. Highly recommend doing that too. So did we succeed at rapid iteration, the real goal, right? Yes. We went from not being able to run a playtest to every day Sprocketeers get into work and they start their day by opening Steam and pressing play. And that's the extent of the overhead that they need to go through to get themselves into a playtest. Everything else is automated. And because we keep the build working, it just works. We use that critically to gather daily feedback on all our work now, and we adjust in real time, which it's not uncommon to iterate the same feature 3 or 4 times in a week. Interestingly, it has resulted in us allowing ourselves to experiment way more. We used to be reticent, I would say, to try things because we didn't know when we'd get the chance to really experience it, get feedback on it, and decide if it was a good idea or not. We now know we will have that chance, so it's much easier to commit to an experiment. And as I said, demo builds are always ready, so way less stress when the time comes to demo the game. So to recap, we went from we using TeamCity, Kotlin DSL, BuildGraph, AWS, Steam, Play Store, altogether. We went from one super high friction playtest every roughly 2 weeks, and those playtests had a, I don't know, 50-60% chance of not working correctly, to a daily, reliable, consistent, enjoyable, and nearly frictionless playtest and feedback loop, of course. This has completely transformed how we work. And if you have multiple developers, I recommend you do something similar. You don't have to do it this way. There's many ways to do it, but like allow yourself to get quick iteration feedback. It will transform how you work. I so strongly believe that. Where do we go from here as Sprocket? The next adventure for us is to continue down the rabbit hole of CI/CD, and that's going to look like automated testing, like a green build with no warning, deployed daily in a demo environment, always being ready is great, but it's just the beginning. I've alluded to that earlier, but without automated testing, we do have instances where even if the game deploys and starts, it doesn't necessarily mean that it's playable the way we expect to, and we do encounter the occasional playtest that's not very effective because the game's fundamentally broken. So we're currently looking into how we deal with that, how we approach making a best-in-class automated testing framework integration. We don't have to write it ourselves. If we can find spots that or products that do it for us, we love doing that too. But that's where our mind is at. If you want to help, stick around. Also, a thing that to be aware of if you get into the how to build Unreal Engine game in 2023, Epic Games is working, has released, but not officially or isn't fully production ready, a thing called Horde, and they define it as a scalable, cloud-ready, distributed build framework designed for Unreal Engine. How well would it work? We're starting to get some talks and some reports that it is looking pretty good, and that could be really useful. But it's a lot of buzzword. We'll see how that comes out. Hopefully, it goes production ready, and we can start playing with it in a more non-testing kind of a way. Or if you have a bigger company and you're willing to spare resources, you could go and investigate it now. Just be aware that it's not blessed yet by Epic Games as production ready, so it may change completely. If you thought this was useful and you want to read more, I highly recommend Googling either of these two talks. Both would be better. The Vela Games about how to use BuildGraph in AWS has amazing gems. A lot of what we did was inspired by them. And June's talk on using BuildGraph is probably the best talk there's out there about how to use that. So strong recommendation on both of these. And that's it. That's me. Thanks. If you love build systems and making systems to make games, and you like to maybe work with us, we have tons of opportunities. So just ping us there. Work at Sprocket.games. If not, that's me.
Woo! We love build systems. That's why.
Yay.
Yeah, let's do it. I have to say, Nick, the journey of your talk was really like inspiring, and I think the thing I took away from it was you've created an environment of fearless deployment and safety at Sprocket Games because the amount of times you can deploy, the amount of times you could roll back to a previous build probably gives people a lot of psychological like safety working at Sprocket Games. So I think if there's one thing people should take away from your talk is like putting these systems in place can really make your environment just that much more fun and open to experimentation and make everyone just kind of feel safe. So I think that's what my takeaway was. Is that a good
Yeah,
takeaway?
it is absolutely.
Yeah.
It's super important for us at Sprocket. Like we great devs and happy devs make great games. I don't know why that would be so controversial, but maybe it needs to be said somehow. And so yeah, like creating that environment when people can do their best work and tools help them truly do that.
Mhm.
Yeah, it's what we believe will unlock the next best generation of games. So yeah,
Mhm.
we're pretty all in on this stuff.
Yeah, and you said something at the beginning which I like it even applies to anyone doing any kind of development or providing solutions for people is like being disconnected from your work is just not good, right?
Oh,
Like
it's terrible. Yeah.
yeah, like you if you can't empathize with like your users, your players cuz you're not experiencing the same thing they're experiencing, like then why are you doing it to begin with, right? So I think that was a really strong takeaway as well from your talk. I enjoyed that moment.
Thanks.
I did hear a couple TeamCity feature requests masquerading as bullet points. I mean, this might be a good time to reiterate those so our TeamCity folks get those. But also, file issues in UTrack. If you have any feedback, our devs are excellent at communicating with our user base and love to talk to our customers. So
I've got
just want
great
to say that.
experience. I absolutely loved using it. Yeah.
Yeah. I did notice something. You said you were running your Python scripts manually.
Hmm.
Our IDEs actually have a file watcher feature, which you can say, like, if these files change, just automatically run this script.
Hmm.
Um, you're nodding like you've tried it. It just maybe doesn't work
Yeah, I
specifically for
mean,
you.
no, it's good advice, and we're always looking for places to reduce the friction. We just have a habit of not reducing it until it causes issues,
Hmm.
or we try to have a keen eye and a keen sense of where those frictions are. And at the moment, that hasn't been an issue for us. So we're a small startup. I mean, 14 people. So some will say we're a small startup. Some will say we're a big startup. I don't know. Depends where you're sitting, I suppose. But so we try to be really lean and only do what's critically needed. I think we'll end up with something like that.
Hmm.
It's made complicated because we let developers choose the IDE they want to run.
Mm.
And so, we experiment with it, having the CI server run the refresh script and then commit back to the Perforce branch. But there's always that weird uncertainty around having a check-in trigger a check-in on your CI server and then it going into a loop. So yeah, because it hasn't been a problem so far, we haven't solved it. But ask me next year. Maybe I'll tell you how we went and solved it and how made
Well,
that bit better as well.
Well, that's a really good point, though. It's like when you're putting processes in place, like you really need to be pragmatic and think about it. Am I just adding process to add process, or is it like really solving a pain point? So I think like constantly iterating, thinking about your process, organically pruning things out, adding things back in. I think that's really great advice. I think so. On that note, I don't necessarily have any more questions. I think the audience were just kind of enthralled by the entire process that you have at Sprocket Games. Uh, I'll give you kind of the stage here. Like, any last comments or thoughts that you want to kind of convey to our audience today?
Yeah,
I'll
I'd
jump
say
in.
too. First, if you're using Unreal Engine, please do yourself a favor and just use BuildGraph. Don't wait. Start with it. You can get it done in a day locally. It's worth doing, believe me. And then the second one, probably the most important one, is recognize your most critical resources. It's your time and your happiness.
Mhm.
If you hate going to work, you're not going to do good work. And if you're always doing unrelated tasks just to get stuff done, you're not going to do the cool shit that you really wanted to do, especially in video games. That's why we are in video games, right?
Yep.
Because we like to make games that are fun, hopefully. So take care of your developers, and if your developer is just you, take care of you. Like, take the time to write the tools that you need to make your process faster. Like do that analysis of, can I make my life better by writing a tool? And if so, yes. But don't go writing tools just for tools. These don't
Very,
result in video games. So yeah, be
very good.
pragmatic about it.
Yep. Don't worry, be happy is what I got. So a Bobby McFarlane thing there. So on that note, Nick, definitely folks go check out Sprocket Games. Definitely sounds like a cool environment to work in. So hopefully you get a lot of job applicants. Just tell them JetBrains sent you, and
Yeah,
then
absolutely.
yeah. On that note, Nick, thank you so much. We'd love to have you again next year. And
It'll be a pleasure.
yep. On that note, have a great day.
Thank you
Thank
so much.
you.
Thanks for having me.